speaking. Hello, everyone, and welcome to this training session brought to you by the Archivists of Religious Collections section of the Society of American Archivists. I would like to start by offering a land acknowledgement, and then I will introduce our speaker. We acknowledge that we live and work on the traditional lands of many Indigenous nations. We know that Indigenous peoples have suffered from historical and ongoing injustices, and understand as an archival organization that we must work towards sharing historical truths and renew respectful relationships with Indigenous communities. We respect the long-standing relationships that Indigenous nations have to this land as the original caretakers. We are grateful for their stewardship and protection of the water and earth. We pay our respects to elders, past and present. So welcome again, everyone, if you're just coming in. Today's topic is keeping bits together, an introduction to digital preservation. And before we begin, I'd like to go over the disclaimers that you see on the screen. The content in these presentations is for information only and is not legal advice. Our views do not represent the organizations where we work, and we do not make any endorsements or guarantees. We are not liable for any loss or damage caused by use of the content we provide. It is your responsibility to critically evaluate the content provided in the presentation or any accompanying materials. So throughout this session, you will not be able to use your microphone or turn on your video. You can click on the CC button at the bottom of your Zoom screen if you would like to enable closed captioning. So under live transcript, click enable auto transcription to get that closed captioning. After our speakers finish presenting, we will have a question period. And please use the Q&A feature in Zoom to ask your questions. Please do not put them in the chat function, just the Q&A button. And I will read them out, and we'll do that in the last 10 minutes of the session. We'll get to as many as we can, but can't promise we will get to them all due to time constraints. We ask that you follow the SAA Code of Conduct and be respectful in your interactions. We will be recording this session, as you are aware, and we will send that a link to the recording a few days after the session. And there'll be a short survey that pops up on your screen just when the Zoom session closes, and we encourage you to fill it out as it really helps us with planning for the future. We also encourage you to join the Society of American Archivists if you're not a member yet. And a special thank you to the Congregation of the Sisters of St. Joseph in Canada for hosting this webinar. And now I would like to introduce our speaker, Grant Hurley. Welcome, Grant. Grant works as the Canadiana Librarian at the Thomas Fisher Rare Book Library at the University of Toronto, where he is responsible for curating the library's extensive Canadian print and manuscript collections. He gained expertise in digital archives and preservation during his role as Digital Preservation Librarian at Scholars Portal between 2016 and 2022. Grant also serves as a Sessional Instructor for the Faculty of Information at the University of Toronto, where he instructs the class Digital Archives Workflows. In 2021, he was awarded the Archives Association of Ontario's Alexander Fraser Award for exceptional service to the archival community, and the MISC Outstanding Instructor Award for excellence in teaching. So we're very pleased to have you with us today, Grant, and I'll pass it over to you.
Thank you, Julia. Thanks for the kind introduction, and thanks to Mary for inviting me to talk with all of you today about digital preservation. So I'll share my screen and we can hit the ground running. So here's what we're going to talk about. Some preliminary introductions, and then really diving in. What is digital preservation? Why is this important as a topic? This may be obvious to you, but maybe it's not. So it's always good to kind of get our bearings. And then I'll really talk about some of the fundamental ideas behind the practice of digital preservation. One of those for me is really understanding how digital files are composed, right? How they're created, how they're interacted with at a physical level. And that helps us also inform what we're intending to preserve, which, like all materials that you intend to preserve in archives, can inform what kinds of practices you take, how much resources you put towards these efforts. And that links finally to discussion of preservation activities and strategies, the actual doing of this work, which I find helps ground a lot of these conversations when we talk about the functional practice of digital preservation. So this person who's speaking to you, as Julia said, his name is Grant Hurley. I work at the Thomas Fisher Ray Book Library. I'm very happy to be working in a special collections environment. Just as of last year, I started this new role. But I've been working in digital archives and preservation for about 6 years in my prior role. So that's where I've learned a lot of this. I should say really at the outset that everything I'm talking about today did not spring from my own brain, like solely, this is what I'm presenting is the result really of a lot of learning from my colleagues at U of T, elsewhere in the archives community in Ontario and beyond, reading articles, going to conferences, soaking in everyone else's research contributions to this field. It's really a synthesis of my own learning, and I'll try and credit folks along the way that have contributed to that learning, but it's really like I think the digital preservation community, such as it is extremely collaborative and supportive, and so my hope is to kind of recontribute to that work by bringing together everything I've learned in hopefully a useful way for you today. I also want to acknowledge that digital preservation happens on Indigenous lands, right? There is a physical component to all of this work, which is easy to forget. And that physical component, whether it's happening in an archival institution, whether that work is happening on a server located somewhere, is located in particularly in North American context on Indigenous lands. I'm speaking from Takarano or Toronto, which is the traditional territory of many nations, including the Mississaugas, the Credit, Anishinaabe, Chippewa, Haudenosaunee, and the Wendat peoples. I'm located in a part of Toronto next to a traditional trail that led from Lake Ontario to Lake Simcoe. It was a really key transit point for moving goods from one place to another. And it has an improper name, which I won't say aloud. It really should be renamed, but its proper name is Makana Anishinaabe, which is a street right next to me. I'm here in Toronto, which means Anishinaabe Trail. And this photo here is from a group called Ogama Makana, who renamed the street sign in kind of an act of resistance, which I think is really cool. All right, so let's start. What is digital preservation? This is the definition from the Digital Preservation Coalition. It's one I return to again and again. You may have seen it before, and I'd like to break it apart, but the definition says, digital preservation is the series of managed activities necessary to ensure continued access to digital materials for as long as necessary. So let's pull that apart a little bit. First up, digital materials. These are digital records that you would like to keep for some reason or another. And the I think thing to note about that is digital materials. They have material form of some kind, from a storage medium on up. And we'll walk through all those things in a minute. Those managed activities for continued access, right? We have activities that are informed by digital preservation practice. The goal is continued access to those materials, right? And so it's important to emphasize that digital preservation is a continuous act of maintenance and care that results in being able to access the materials that you'd like to. The definition also has a time frame, which is as long as necessary. As long as necessary is more realistic than forever. Sometimes we talk about preserving things in perpetuity, which feels big and scary. The future is wildly unknowable, as we have all experienced over the last few years. But for as long as necessary puts a bit of a boundary on that and says, this work may happen in the short term, it may happen in the medium term, it may be intended for the long term, but it's really about handing the work from one person to another, often in an institutional context. It may outlast you as an individual who contributes to this work of preservation. Ideally, it does in many cases. And that's why it's important to follow practices, to start to refine them, to document them as well, and to contribute to this work on an ongoing basis, and one that you can hand off to hopefully your successor in the future. But in other cases too, it may not be required to maintain digital material forever. Maybe a shorter period of time is all that's required for one reason or another. Another thing to kind of note, as I said, is why is digital preservation important? Of all the things that you probably need to do on your day-to-day basis, thinking about or doing digital preservation work can be hard to find time for. But the thing that I always come back to, at least in my own practice, is that the records created by the communities and individuals that archivists are responsible for acquiring and stewarding are no longer only in analog form. We know that, right? And they haven't been in analog form exclusively for decades now. People have been using computers actively since certainly the late 80s, when personal computers became really common in many households, and certainly more recently, right? And digital only collections are increasingly becoming the norm, right? In a lot of situations now, archives are accepting hybrid collections more frequently, right? Where there are paper or analog materials alongside digital ones, some combination. I see in the future that people, particularly those working now in remote work contexts, or who aren't relying on printed copies of things, are going to be wanting to donate their materials to archives, whoever they may be, whether it's in an organizational context, and it's coming sort of from a records management point of view, whether it's private donors donating private records. But if the archives can't accept these materials and provide evidence that they're able to preserve them, those records creators are going to go elsewhere or not bother, right? And so there's this threat of a possible huge gap, really, in the archival record. Another thing I think is important to clarify is how this all fits together. And so I wanted to find some terms at the outset as well. So when I think about digital archives, to me, those are the collected activities that together ensure the trustworthy stewardship of digital archival records, from the point of acquisition in an archival context through to access. Digital preservation is a somewhat narrower set of activities that fit within the work of digital archives, that complement the work of digital archives. I use the same definition here, but I should note too that the work of digital preservation can apply to many different contexts as well. It certainly is important in an archival context. It's important in a library context. It may be important though in other industries and worlds. Anyone who's interested in keeping digital information for a medium or possibly long term, even a short term, really, when it comes to how quickly technologies change, have a stake in digital preservation. And so it can be kind of cross-disciplinary. It's certainly relevant though to the GLAMs or the cultural heritage sector. Finally, you might hear a phrase called digital curation circulating out there. And that's a related practice, but it's really about adding value to data of some kind. And there's a sort of a curatorial aspect to digital curation, which means maybe improving information about digital data that you'd like to keep. It's often talked about in a research data context or a data archives context. Might be about creating metadata. And it's related and supportive, I would say, but not core to our conversation here today. I've mapped out some of these activities as well, and kind of color coded them here with supporting fields. So when I think about digital archives, I'm thinking about records transfer in records management context, or acquisition from donors. And that's of course supported by the field of records management, as well as personal digital archiving, which might be advice that you give to individuals for organizing, maintaining the digital files while they're still under their own care. We talk about media migration and digitization as well. So that's retrieving data off of either legacy storage media like floppy disks or hard drives, but also creating new digital materials from analog versions, right? So many of you probably have digitization activities that you're undertaking all the time. And so that, of course, has its own set of standards and practices and is quite distinct from digital preservation. If there's anything you take from today's conversation, it's that if you are doing digitization work, whether that's scanning or converting magnetic media to digital formats, tape or video, that's creating digital materials that themselves require preservation. There's not a lot of point into putting all this labor into digitization, particularly when you're digitizing for preservation purposes, because that original item may be degrading in some way without some kind of digital preservation strategy in order to maintain those files into the future, right? And again, for media migration, disk imaging, digital forensics, they're their own fields as well that support this work. As archivists, you're probably familiar with appraise and selection and accessioning. That's archival practice, of course. It's part of a digital archival workflow. It's supported by digital curation as a practice as well, complemented by, I would say, although there's less of a conversation there. And then all the things in green are what I consider part of digital preservation proper. And we'll talk about these things today. Preservation processing, preservation metadata creation, questions around converting file formats to migration or normalization, emulation, which is a kind of new exciting area, and questions of storage and monitoring and maintenance. And finally, those two boxes in red are about access, right? So and that could be through archival descriptions that you host online, it could be access to digital materials in a reading room context, it could be platforms that you host online with digital collections, it could be exhibits, anything that really allows access to digital records. Of course, for all these activities, there are people that have to do this work, right? And so the digital archivist in this view is responsible for designing those workflows for acquisition, appraisal, and selection of digital records. They may be themselves processing records for preservation and creating archival descriptions and access copies, and perhaps mediating access to materials in some context, as I said, either in the reading room or perhaps online. A digital preservationist is really focused on long-term integrity and accessibility of digital materials through preservation strategy, which we'll walk through all in a minute. In some institutions, these are separate roles. You have a digital preservation person who may be supporting preservation activities across the whole organization. In many cases, especially here, I've noticed in Canada, it's one person doing this work, right? You have an archivist. They may or may not be even specifically a digital archivist, and they're responsible kind of for it all. But in the kind of ideal world, you have these complementary responsibilities that support and collaborate. But it will vary very widely, very widely according to your institutional context. And as I said, this role of digital or data curator is possibly complementary. They're tasked with accepting and evaluating data deposits, creating or ameliorating metadata, checking data quality, performing cleaning or de-identification to improve accessibility, preservability, and discoverability. And as I said, this often is more in the context of research data or data archives, but you could say the same thing about some roles of the digital archivist when it comes to archival materials. So I think it'd be interesting to see more connections between these two kind of complementary areas. All right, so we'll go back then to this definition of digital preservation. One thing I want to note at the outset really is that if you take away the word digital from this definition, this could apply to all materials in archives, really. Analog materials require ongoing support to ensure continued access. We know this because there's a whole field called conservation, which is dedicated to this work. We don't think about it in the same way sometimes, in part because timescales are longer, right? Like a piece of paper is going to last longer without intervention, sometimes than a digital file. But the broad goals of digital preservation are not different from the broad goals of analog preservation programs. So what makes things different then? If the broad goals are the same, what makes preserving digital different? The one is that there's a greater layer of mediation between a physical file, digital file, and you, the person who wants to access it. And so we'll talk about that in a minute as digital files as links and layers. Another is that you have a choice of preservation priorities. I would say this is the case for analog materials as well, although not quite as direct, whereas in digital materials, you really can be more specific about what aspects of the digital material you'd like to preserve, or what are important to you. When it comes to preserving a photograph or a piece of paper, it's the whole object generally. I'm sure there are many exceptions that people can think about, but with digital materials, there are items that may or may not have different priorities or aspects of those items. Another thing which you probably experienced at some point in your life is that it's very easy to delete, modify, or corrupt digital materials, right? With a piece of paper, you have to get up and like shred it, throw it away if you want to destroy it. They're hard to modify in the same way. Whereas, of course, with digital materials, pressing the wrong button, accidentally deleting something, having a computer crash on you, happens all the time, right? And so we need to mitigate that risk through a practice called bit level preservation, which I'll walk through in a second. And then one of the other advantages is the ability to automate metadata extraction and format migration, which helps facilitate the management of digital materials over time. This is not as easily done with analog materials. And so that's when we talk about key preservation functions. So we'll start with the first, digital files with links and layers. So I'm convinced that doing digital preservation well involves having some understanding about how digital files are composed. And the thing to always keep in mind is that all digital storage media has a physical instantiation somewhere. And they all have different ways of recording information on that storage medium. Some of you may have experienced punch cards. I have not myself. That's one digital storage medium, although the medium itself is not electronic in any way, but these are used to run computers. Floppy disks may be more familiar to many of you here. Flash drives, of course, are ubiquitous. And then, of course, we have servers, which are now ubiquitous everywhere in the world, which also store digital information. The patterns will vary. The ways in which patterns of information are recorded on these storage mediums will vary based on the technology. Floppy disks are magnetic media, whereas flash drives use charges and tiny cells. It's fascinating. The mechanics of this stuff I find really interesting. But the basic point, one way or another, is that those patterns of recording on a physical medium somewhere translate into bits, zeros or ones. That famous kind of unit of computation, right? Yes or no, 0, 1. You string together 8 of these, and you get a byte. There's a way of summarizing that string of zeros and ones. It's a hexadecimal value that it's mathematically summarized. You string together more than one set of bytes, and you get a bit stream. And suddenly that can become a file, basically. So a string of bytes that ends at some point, has a beginning and an end, really, is a file. And so if we have, for example, 48, 49, 21, those are hexadecimal values, summaries of binary values, those then mean something, or they can mean something. And so I'll show you an example here. I'm going to share my desktop here. This will work. We look at some files. So this is a text file. Very simple. It says hi, exclamation mark. If we open this in a hex editor, which is a way of looking at the hexadecimal values, you can see it says 48, 49, 21, which is what those values are mapped to in the ASCII text format. So ASCII text is a basic text format. And there's a literal table that says 48 equals the letter H, 49 equals the letter I, 21 equals exclamation mark. We can take a look too at the binary values, right? So that's what they translate to in binary numbers. This is very simple, right? 3 characters, single, simple ASCII-based text file. If we open up this image, this is just a common JPEG in a hex editor, it's way more complicated, right? You see like strings and strings of zeros and ones. There's lots of information here that corresponds to all the pixels in the image, right? It also includes metadata about the image. There's a structure to these files. And so they're much more complicated to interpret. But the same principle essentially applies, right? You have a set of bytes that begin and end. There's a bit stream that essentially means that we've got a file here. I hope I'm back on my slides here. But if I'm not, just let me know in the chat. So that's what I mean by layers of mediation. We've got the storage medium, the physical medium on which data is recorded and stored, right? There are many layers after that. So up next is the operating system, which is a set of services that connects the physical components of your computer to software. So how you connect your keyboard and mouse, your display or printer. It brings together memory and storage and networking and allocates resources to all these functions. So the basic operation of a computer, essentially. And so many of you will be familiar with like a Mac operating system or Windows operating system. Operating systems themselves also have file systems, which for the interest of archivists, delineates how and where data is stored by the operating system, how it retrieves data from the storage medium. So it's what connects us to a storage medium, like a hard drive or a floppy disk. And includes rules like file naming, how you create directories and folders, what kind of metadata can be assigned to those things. Different file systems have different rules. If you've ever tried to like name a file with a particular character in Mac or Windows and it says, oh, you can't do that, that's the file system. And some are older or newer than others, right? Some are more or less compatible between them. I'll talk about that in a minute. And then, of course, we've got file formats, right? So you have streams of bytes. Interpreting those bytes with software have rules and structure for how they should be stored and interpreted by that software. And so different file formats have different sorts of rules that say, okay, here's the set of rules for ASCII text, right? There's a table that essentially just maps characters to hexadecimal values. For JPEGs, it's more complicated, right? The structure of how to interpret sets of bytes as points, pixels of image data are more complicated, but they're literally human created sets of rules for what sets of bytes mean what kind of information. And files, of course, get created by software, right? Which are a collection of instructions that tell a computer how to work, how to create those bytes in collaboration with you, right? In the creation of files. So you have a piece of software that's going to create those files generally according to those rules, such that they can be interpreted by the software again. They can be exchanged with people who are able to use the same software. You can send a Word file to somebody else, and they're able to open it for this reason. The point is to be able to exchange information and have it represented roughly in the same way from one person to another. And then finally, we've got that output, right? Like you interact with a computer, usually through your computer monitor. We live now in a world of devices with surfaces, right? Tons of monitors everywhere, your phone, your laptop, the touch screen on like restaurant, like those are all interfaces on computers, right? In the past, the only way to interact with a computer often was through a printer, but that's another output, right? That's possible. And just as there are all these links, right, from the physical file through the operating system, the file system, the file format, software interpreting that file format to your screen, things can break, right? And so when things break, the job of a preservationist is to figure out where in that chain the break happened and try and fix it if possible. So those breaks can happen at this level of the storage medium, right? Maybe you don't have access to a zip disk drive anymore. For those of you who've ever seen a zip disk, it's like a fat floppy disk, thick and hard. And so maybe you have to buy an old disk drive, right? Perhaps the storage medium is damaged, right? If you scratched a CD or maybe you dropped a hard drive, you may or may not have luck getting data off of that medium. When the storage medium is damaged, it's interrupting access at that physical level, and it can be much more challenging to retrieve data. There are services out there that can help you do that. There's a cost to those, of course. If you've got a storage medium, though, it's in good condition, physical preservation of storage mediums is important for that reason. Then the rest of the links kind of have to be put into place. So is it was it created using a compatible operating system or not, right? Is it compatible with current functioning computers? As I mentioned, operating systems really link the physical components of the computer to software. And so different ways in which computers have been physically constructed over time can sometimes cause issues. And so that's when to fix those issues, that's when you use things like emulators, which run old computers within new ones, essentially. File systems are similar as well in that older file systems may be incompatible with newer ones. And so there are different tools out there where you can interact with legacy file systems using current ones. Our file formats are similar in that because they're human created and human maintained, some of them become obsolete at one time or another. If you can't open a particular file in the present day, it may be because that file format is no longer compatible with the software that you have available. And there are tools out there that will help you convert file formats one to another if this kind of thing happens, or you could use an emulation approach where you're running that piece of software again within a newer computer, but kind of like in its own enclosed space, to put it simply. Software is similar in a way. Having access to legacy software can help open files, but if you can't, again, there are programs out there that can convert them. Classic example, a program called WordPerfect. It was one of the kind of dominant word processing applications up until probably about the late 90s, early 2000s. You can't open it with Microsoft Word. That software isn't really available anymore, as far as I can tell. But there are compatible, there's compatible software out there that can open WordPerfect files, or you could use, again, an emulation approach. It gets harder again when you get back to that physical level. So in some instances, access to specific type of display or printer might be required. This comes up more frequently when you're dealing with like really old stuff from the 80s, where like there was a really close relationship between the computer and its physical, or the software in the computer and its physical construction. And so sometimes that means finding old hardware or converter cables to make these things work. But I think it's more of a computer museum kind of context rather than what you would see in the day-to-day. And then, of course, there's all these other issues that come up, right, that aren't quite related to the common things that I've talked about, although these are common too. Because we live in a world now where a lot of access to software or applications are subscription-based, you may be losing access for other reasons, not because of obsolescence, but because you can't afford to pay for that service anymore, or don't want to, or that service went out of business, or was discontinued. It happens all the time. And so that kind of loss of access is another reason to do preservation work. There are user-created locks as well, things like lost passwords, or locked or hidden files. In that instance, we talk a lot about working with donors, ideally while they're still alive, to help mitigate those kinds of issues. But these are equally relevant, and I think simply require similar kind of preservation strategies. I'll note as well the importance of recognizing moving data between mediums. So as I said, digitization is one aspect of that, where you're either conducting it for preservation, where the digital copy is intended to eventually replace the analog one. And this is especially the case where your analog source is degrading in some way. Magnetic media, like audio cassettes or videotapes is a great example of that. Digitization might be happening for access purposes as well, where you're simply just wanting to get information online or accessible to your user community. And that's less of a concern for preservation purposes. Generally, when you're digitizing for preservation, the level of quality that you're putting into that capture is very high. And that's where you really want to be protecting the investment of the time and resources that you put into digitization. So the only thing to know here is really that when you're doing digitization for preservation, you really do need to think about preserving the outputs of that work. I won't go into detail about this today because it's its own thing, but again, retrieving data from storage mediums is its own field. This is what we normally call disk imaging. You're creating a complete copy of the original storage media, whether less commonly done for CDs, but certainly hard drives, floppy disks, and flash drives. It requires its own hardware, often like a disk drive of some kind, or some way of accessing that original storage medium. Many institutions use BitCreator as the processing environment for those materials. There's a guide that I published as part of when I was at Scholars Portal called Handling Digital Archives Before Ingest, which discusses a lot of these things. If you're interested in learning more about this area. There's so many resources out there on this topic, though, and it's as I said, it's its own fascinating subject. So you've got floppy disks in your archives, you don't know what to do with them. Those are some places to start. We can talk about that more too in the discussion. But to move on to the question of what we are preserving. It's important to kind of, I think, to see that relationship between the bit streams, right? We talked about the physical components of files as bytes, becoming bit streams, becoming files, right? We have these increasing levels of aggregation, and that aggregation continues. It's all the way up, right? Just increasing aggregations of things. So one or more bit streams makes a file. One or more files can become a digital object, which I'll talk about in a second. One or more objects becomes a record. And now we're talking about, or in the area of archival terminology, where everyone's probably a little more comfortable. Of course, more than one record becomes a collection or a phone, as we use in Canada especially. And one or more collection is an archives, right? Ideally, you have generally more than one set of materials in your archive. It's funny that I still find it lightly confusing that we call digital files files, whereas paper files are groups of records, right? If you have a paper filing cabinet, you have a file and there's multiple, often records within that file. The reason is that computer files are groups of bit streams. And so that's why they're called files. But we often talk about preserving digital files or computer files as digital objects. And so when you hear about the preservation of digital objects, it is what Christoph Becker calls a metaphor. It's a jump from the physical to the conceptual. And so it has kind of subjective boundaries, but the digital object, to be brief, is the thing we want to preserve. It's whatever the subject of preservation activities is going to be. That thing may have many components. It could be stored more than one location. It could rely on different pieces of hardware or software. But it's whatever you've identified is something that you want to preserve. And that could be very simple, single document, right? Or it could be like a website, right? And so figuring out first what that is kind of the first step. Functionally speaking, a digital object is one or more sets of bit streams or files that together create an intellectual entity, right? And as I said, that could be a document, it could be a scanned book, it could be a single image, it could be a number of different things. There's some nice examples of this, how this works on a functional basis too, I'm going to point out. So you have an EPUB, right? That's an electronic book. This is an example of Pride and Prejudice. An EPUB actually consists of a zip file with a series of folders in it. And those folders contain individual HTML files, which comprise the text of the book. Those HTML files also may have linked images if there are pictures in the book. But an EPUB is basically a website. And so the digital object is the EPUB, but it has multiple files that contain it. I'll share my desktop again. I think I still am, so hopefully we can see this. But if we go back to a set of files here, I have a Word document here called a couple words. It is a Word document with the phrase a couple words. If you unzip it using any kind of like file unzipping utility, it's actually a file folder. It's composed of different folders. And within that is XML files. And if we open one of these XML files, it actually is the content of the Word document. Another has the styling, like the fonts and things like that I might have applied. So it's all these different files that are working together when you open up a single Word document. You don't see this though when you open it up normally, right? You see a Word document, you interact with it, you save it, you close it. This is all happening kind of under the hood. But this is to emphasize this aspect of digital objects in which they have many components often. And essentially it becomes another place where you may be identifying preservation issues. So as I said, each rendering of a digital object recreates it anew from those interactions of the layers on that chain, from the storage medium on up, really. And so Christoph Becker, again, a great article from him about this subject, says to preserve digital objects really means to design sustainable systems intended to reproduce what we call digital objects. So that's where the kind of practice of digital preservation comes in. The other aspect is thinking about what you'd like to preserve. And we talk about these as significant properties. This is the characteristics of digital objects that you'd like to preserve over time to ensure continued accessibility, usability, and meaning. Significant properties are in the eye of the beholder, right? So what characteristics are significant to your community, who values them? That could be informational content, it could be appearance, it could be interactivity, right? There's an example here of a manuscript by Margaret Atwood, Canadian author. His papers are at the Thomas Fisher Library. And you can open that manuscript in a text editor and see the content, right? You can read the text for the most part. It looks okay, it's readable. But if you really want to know how Margaret Atwood interacted with that file, you can open it in an emulated version of Mac Write 2, which is the piece of software that created it, and really see like what it looked like to her when she was writing it. Different communities may have different needs when it comes to preservation. Knowing your community's needs is important here. Do they just want the informational content? Do they want to interact with it in this kind of rich legacy software environment? Those options are there for you, right? And maybe both are acceptable depending on the kind of resources you have to support them. So I'll briefly kind of run through some of these key activities, right? Maintaining those links and layers. And this is really where the topic of maintenance, right, comes to the fore. So the first kind of thing that one does is keeping files safe using bit level preservation strategy. Bit level preservation is when checksums are run against files and verified to be unchanged, and those files are stored in multiple locations. A checksum is an algorithm that's running against a bit stream, and it produces a unique alphanumeric string. They're based on the bit streams in the file, and when the bytes are changed, the string also changes, meaning that your file has lost integrity. There are different types of checksums available, which you may have heard referred to, but the basic principle is you run a checksum at one point, record the date and time in the output. It's the string at the bottom here, CF8, E8, yada, yada, yada. If you run it again at a later date and time and it matches, then you know your file has maintained integrity. If it doesn't, something's happened. That file has become corrupted in some way or altered, right? And so the checksums establish fixity, which is the quality of knowing that a file hasn't been altered or changed in any way. And so when a file is 60 and you have evidence of that, you've recorded that information, we can say it's retained integrity and therefore can be trusted. If it hasn't, then the importance of storage really comes in, of having multiple copies. Bit level preservation doesn't guarantee any form of future usability or accessibility. You just know that the files have integrity. It won't tell you what happened or why it changed. But it's really the most basic form that digital preservation work takes. You're running checksums against preservation files, you're recording the outputs, you run that again at a different time, compare the output. And if everything's good, everything's good. If not, you have to investigate and pull out another copy from another storage location. And that scheduled checks will depend on the context, scale of your collections. It takes computing resources and energy. So being strategic about when and how to do that is its own conversation. But as I mentioned, storage is kind of a key component of this, right? So safe digital preservation storage is a cornerstone of digital preservation work. It's not the only thing, but there's really no preservation without storage. It's always kind of funny to me that we put all this effort to get data off of one storage medium, put it on another, right? Getting data off of flash drives or floppy disks and putting them on servers. They all have a physical component, but the difference is that one is not managed and possibly at risk, and one is ideally managed and maintained with the intention of preservation behind it. People talk about questions of copies. More than one is the kind of baseline because of that need to replace files that maybe have lost integrity. There are different types of copies that you can talk about, whether they're linked for availability only, reliability. They could be on independent storage media or different storage methods. You could have them in different geographic locations. I know you had a presentation from the folks behind the NDSA levels of preservation last month, and they talk a lot about this in detail and have a really useful framework for assessing storage and integrity approaches. So many of you may be familiar with that already. There are different preservation storage options out there. They each have pros and cons, like anything. So between tape as one option, which is expensive but very reliable. Many folks use cloud or other sorts of distributed networks, which can be cost efficient, highly reliable, but you're outsourcing it essentially. And then based on resources too, local storage, whether that's series of connected hard drives or maybe local network storage, can be used depending again on whether you're doing it, I guess, responsibly. We can talk about that in the Q&A as well, but storage is probably one of the more resource intensive parts of preservation, digital preservation work. And so you do with the best of what you can. All right, I'll brush briefly through preservation actions that extend beyond the bit level as well. So these are some other things that institutions will start implementing after bit level preservation. The first of these is file format identification. We talked about file formats already, which is a convention that establishes rules for how those bytes are structured and stored in a file. And of course, file formats enable us to store information, exchange information. Ideally, they're structured in the same way. For many years, of course, there was concern about proprietary file formats, which lock users in to a particular piece of software. This has become less of a concern as markets have demanded, users have demanded interchangeable file formats. And so not quite an issue, I would say, as it was in like the 90s. But it's certainly, there are plenty of examples of proprietary formats out there from that period and also today. The basic piece of information that you need is what the file format is, though, right? That helps you inform those preservation and access decisions. And the key thing is to identify the file signature rather than its extension. A signature is a series of bytes that occur in a predictable manner at the beginning or an end of a file. And they're more trustworthy sources of information about files because extensions can change. They're not standardized in any way. You can change them yourself. Often the computer will let you do that. Opening a file in a hex editor will allow you to see those series of bytes often. This is an example from PDF 1.5, highlighted in gray at the top. It also has an end of file marker required for successful identification. And we're blessed with a very wonderful resource called Pronom, which is a database of these signatures. And so many tools that identify file formats will query Pronom. Not all files can be identified this way. Plain text files don't have signatures, so you have to identify them in other ways based on their content or structure, sometimes extension. But there are various tools, again, that will query Pronom. And having this knowledge about file formats is probably the kind of baseline activity that you need to do. So if I go back to my screen here, I see this file called passage.bk ! I can run a tool called Siegfried against that on the command line, and it will spit out information about that file. It tells me it's a WordPerfect document. It's querying Pronom. It gives me the Pronom identifier, so I could find out more information about WordPerfect. And so just knowing that it's a WordPerfect file, if I can't tell like just by looking at it or trying to open it on my computer, my Mac will say, "Oh, I don't know what this is." Let's see here, share my screen. Knowing that information about the file can help, of course, inform what you do with it, right? There's a couple of other functional aspects of preservation activities, including file format validation and characterization, I'll just kind of briefly touch on. They are more advanced, I would say. One of them is validation. So like we talked about, the rules for how to structure file formats. You can check the structure of a particular file against those rules using validation tools if you want to know if the file is essentially well made by a piece of software. And this is useful particularly when you're trusting software to make good records. If you're in a records management context and you want to know that the PDFs that are being signed by members of your organization are trustworthy, well-created PDFs by software, using validation tools could be helpful for you. Characterization is a secondary activity as well that extracts additional information about files that may be useful to you. So metadata added by users, metadata added by software, like creation, modifications, timestamps, and geolocations, which could be useful for archival description, or information about the file's contents. I have a list of tools here, which you can look into if you're interested. They will do different aspects of this work, usually related to different broad categories of formats. But I'll share the slides out afterward as well. And you can investigate those links further. Lastly, you may be interested in the topic of file format normalization or migration, converting files, right? So can you convert the file to new format? What gets changed in the process? Is something worth investigating. The one kind of terminology thing to note is that normalization means converting to a standard set of formats when you receive materials into your archives. Some archives do this as a practice. They want to control a narrow number of file formats. Others use a migration strategy where you convert to new file formats when it's threatened or obsolete. And there are preservation and access purposes to this work as well. So maybe you're creating copies for preservation purposes. You generally want to just have a second copy as a kind of just in case version in a secondary format. More commonly, folks do this for access, right? So you're creating access copies for your user community in a format that they need and require. And as a bonus, emulation is its own strategy, particularly for access, right? So you're accessing files within the originating operating system, running them together. Sometimes this is the only preservation method if that software is really closely tied to hardware or can't be opened in the current operating system. And there's a wonderful project called Easy, which is developing all sorts of tools and resources for this work. And I think it's going to be increasingly accessible and available in the coming years. So briefly, just before the end, this is kind of bringing it all together. I've mapped out these tasks into a workflow here from acquisition through to access. That work of digital preservation, again, is in the green. And so starting the journey of preservation means first identifying what materials you've got in your archives. There's a template resource here linked that I used at Scholars Portal, which can help you with this. And it means asking questions, right? What kind of materials do we have? Where are they stored? What formats are they in? What materials might be at most risk? And at that point, you're starting to control the materials once you know what you've got. That might mean moving files to safer storage, whatever kinds of resources you have to support that. Whatever you do, don't keep data on unstable storage media like CDRs or flash drives, keeping only one copy, or making files editable by staff in a shared drive. Those are kind of no-nos. Institutions who want to move beyond this may implement fixity procedures using different applications that are available for this work. Producing file format identification reports using tools like Brunhilde or Droid. And then even going beyond that, producing converted files or using emulation strategies. Some institutions then use bespoke software for this purpose as well. If you've heard of Archimatica, which is an open source tool for automating a lot of this work, including file format conversion. Preservic has a paid version as well. But I'll end there. There's lots of information about this topic online, which I've linked to as well. These are some of my favorite resources for learning more about digital preservation. As I say, this is the end of this presentation, but the work of preservation never really ends. So I'm happy to, in the few minutes we have left, discuss a few of your questions.
Wow, thank you, Grant. That was a very comprehensive explanation. I learned a lot, so really,
Great.
really appreciate it. And I took down some good notes for things I can say to the board that I report to about explaining some of these things. We have a few questions for you.
Great.
Morgan, not having the hardware software to view or access a file is an interesting problem. Is it always important to be able to access, view the file? Is keeping an unviewable file ever worthwhile?
That's a great question. So I think that is where digital preservation questions can sometimes inform essentially what are like appraiser selection decisions, right? And so if you know that the contents of the file are valuable for an archival context and a research context, it is usually worth keeping them in the hopes that there's some way of accessing them at some point in the future. In some cases, though, you may have a sense of what the materials are and realize that it's not worth the effort. So a good example is that I was working at an institution some years ago who had a whole lot of accounting files in this proprietary accounting software format. And they decided that not to keep them. It wasn't really worth preserving them because they knew that that accounting information was recorded in other places through budget documents, through annual reports. And so it didn't have long-term value. And therefore, it's kind of easy to say, well, we don't really need to preserve these. So I think, yeah, that's an interesting example.
Okay, great. What is your opinion on PDF/A? Should we always use it instead of PDF? My understanding is that it's useful for born digital documents, but not so much for digitized documents.
Yeah, I think your understanding is correct. Converting digitized documents to PDFA doesn't add much. It's just sort of, I think it's kind of just reconverting it into the same thing. PDFA is, some people think the A stands for archival, but from what I understand, it actually is accessible. And there's a fellow named Marco Clint who wrote a very great presentation for iPres some years ago on PDFA. If you can dig it up, or I'll see if I can dig it up, it's very entertaining. It's kind of like a hot take. But yeah, creating PDFAs from born digital documents is good practice, especially when there's interest in making those kind of like standards-based, it's the file of record, right?
Right.
But there's no sense really, in my opinion, converting them to PDFA if it's a digitized document.
Thanks. Okay, I think we're going to take one more question. We'll stay a little past, a couple minutes past the hour if people need to go. What do you recommend for checksums or preservation standards for an entire institution to successfully complete file migrations from network drives to cloud storage systems like Dropbox or SharePoint? Big question.
Yeah, that's a good question. I'm trying to see if I can read it again because it is very large.
So they need to do checksums and preservation standards for their file migrations for, it sounds like, everything. Maybe that's just too big a topic for now. But if they look back through your presentation at the beginning, I think that provides some guidance on where to start. Essentially,
if you're really looking at an organizational shift, that would be the point where you'd want to investigate dedicated software to automate that work. So you can't be doing it on a kind of bespoke basis. Right. Having either paid software or open source software that's automating that process, making it repeatable and consistent is kind of where that work needs to happen. But starting with the storage aspect, like figuring out what you're going to be using for preservation storage is where I would begin, right? Because the software is always going to have to interact with some kind of storage, whether that's on a cloud or something else. And so identifying like what kind of preservation storage can you afford and use is the first step. And how much data do you have, right? That'll kind of inform that decision. Okay.
Well, I want to thank you, Grant. I'm sorry, folks, we can't get to all the questions. We do actually need to end at 4, I'm told. So, but that was really, really great. And Grant, we'll talk to you about maybe how we might be able to share your slides if we could do it through Google Drive or something like that. We can talk later, and hopefully we can share them with all of our interested listeners. So thanks again very much. And thank you to everyone for being here, and enjoy and come to our next session on June 8th if possible. Thanks again,
Thanks for
Grant.
having me. Thank
Thanks,
you.
everybody. Bye-bye.
Bye.